Hello and welcome. Today in geometry, we're going to learn about the areas of irregular polygons. And you may be wondering, what is an irregular polygon? A regular polygon is a polygon whose sides are not all the same length or whose interior angles do not all have the same measure. For our first example, we're going to take the area of the maple leaf on the Canadian flag. So to this, we're just going to have a simplistic drawing right here. And we're first going to divide this up into different shapes. So right here we have a rectangle, here we have a trapezoid, and here we have 3 pentagon-like leaves. So what we're going to do is first take the area of the rectangle, which is a length times width. So that's going to be 1 times 5, which equals 5. Remember that 5 was our length and 1 was our width. Now we're going to take the area of the trapezoid. So remembering that the area for a trapezoid is 1/2 height times b1 plus b2. So that's b1 right there, that's b2 bases, that's the height. So what we're first going to do is take 1/2 times the height, which is 4. Then we're going to multiply that by base 1 plus base 2. So that's going to be 3 plus 9. Remembering that that's base 1 and base 2. And then what we get from that is going to be 24. And now we're just going to take the area of those pentagon-like leaves. So to do that, we're going to have a square and a rectangle for the actual pentagon, but we have to subtract these 2 little triangles right there to get the actual area. So we're going to just have 4 times 4 for the square, plus 4 times 1 times 1/2 for the big triangle, then minus the 2 little triangles, which is going to be 2 times 2 times 1/2 times 2. And so for that, we're going to get 16 plus 2 minus 4. And what that ends up being is 14. So that's the area for one of the little pentagons. So when we're taking the area of everything, it's going to be the rectangle plus the trapezoid plus 3 of the pentagons. So we're taking 5 plus 24 plus 14 times 3. 5 is the area for the rectangle, 24 is the area for the trapezoid, and the leaf is 14 times 3, which all ends up being 71.
Okay. Next, we're going to take the area of a crop circle. To do this, we must realize that it is a hexagon inscribed inside of a circle. We're going to find the areas of the shaded region. To do this, we have to realize that they are made out of equilateral triangles. To take the area of the shaded region, we take the area of the big circle minus the hexagon, and then we will get the areas of the shaded region. We must find the radius, which is given as 6. This means that the diameter is 12. The area of the big circle is pi r squared. And since the radius is 6, we will square the 6. And we will get 36 pi. The area of the hexagon, how do we find this? We will find this by finding the area of an equilateral triangle. And in this one, we have 6. A triangle, an equilateral triangle, can be seen as a 30, 60, 90 triangle when we divide it down the bottom. The ratios are 3, 3 root 2, and 6. Since the area of a triangle is base times height times half, we will put in the base, which is 6, put in the height, which is 3 root 2, and then we will put the times half. And this equals 9 root 2. This is the area of one equilateral triangle. And since there are 6, we're going to multiply that number by 6. which we get is 54 root 2. Therefore, the shaded region must be 36 pi, which is the whole circle, minus 54 root 2. And the answer that we will obtain for the shaded area will be 36.73. Finally, we're going to take the area of this cat. We're going to take the area of the shaded region, which excludes the eyes and the nose. To start off, we're going to assume that the radius of the eye is 3. To find the shaded region, we'd find the area of the big circle minus the 2 little circles and the little triangle, which area is given as 2. And this will give us the area of the shaded region without the eyes or the nose. The area of the bigger region is pi r squared. And since the given radius of the big circle is 10, we plug in 10 in pi r squared, which gives us 100 pi. Next, we're going to find the areas of the little circles. We're going to find the area of 1. Like the last one, the area formula is pi r squared, and since the radius is 3, we're going to get 9 pi. That was the area of one of them, and since we have 2, we must multiply the answer by 2. And we get 18 pi. So the area of the shaded region equals 100 pi minus the area of the 2 little circles added together, 18 pi, minus the triangle area, which is 2. This answer will be 255.6.